Now here we have three figures to understand the Pitot tube further, right, because this was the device which he developed basically. This is a open channel flow, this is a flow in a river, this is a river in which water is flowing and here pressure is equal to atmospheric pressure, right. So this is a free surface, and if we have a tube which is tilted in this manner, and if this portion of the tube faces the flow, then this velocity v is retarded to 0 at point A. Now this will exert pressure in this direction, and static pressure at this point, at this particular point, let us say, will be equal to pressure equal to height. This height will offer some pressure, and here this height is the difference of total pressure minus static pressure. So this h can be related to velocity v is equal to root 2g h. So by measuring this h, we put in this formula, we can find out the velocity at this point in a river, right. Now if we want to use this same device for finding out the velocity in a pipe, in that case we must know the static pressure at that particular point and stagnation pressure at that particular point. Then only we can find out the velocity at that particular point. So basically we have to combine two tubes. So two tubes measure the pressure difference between static pressure and stagnation pressure, right. So we, for that we have to redesign the tube which is known as Pitot static tube. So let us understand with the help of these two figures. In this figure we have a Pitot tube which is built in this manner, and we have another tube which is also known as a piezometric tube. So at this point, which pressure will be measured? This pressure which will be measured by this tube will be known as piezometric head or static pressure at this point. Now this velocity is retarded to 0 at this point, and this one will measure P over rho g plus v square divided by 2g, this whole height. So out of this difference and this difference will be known as basically kinetic head v square divided by 2g. So we measure this difference here and put equal to v square divided by 2g. So here v is equal to root of 2gh. With the help of this we can find out. So this both tubes are merged here in another device which is known as a Pitot static tube. In Pitot static tube we have a tube which is known as a Pitot tube. This tube measures which pressure? This tube measures the total pressure or stagnation pressure, because this n is facing the fluid and here velocity is retarded to 0. Now this tube is surrounded by another hollow tube, right, this hollow tube, this is a hollow tube, this is a hollow tube. Now at this hollow tube we have a hole, or this point and this point, there are 4-5 holes at the periphery. Now these holes will measure what pressure? Static pressure or stagnation pressure. Since these are parallel to flow, so these holes will measure static pressure. Now these holes will measure static pressure and this hole is measuring the stagnation pressure. So these two tubes can be connected to manometric limbs of two limbs of the manometer, and that manometer will measure the difference between stagnation pressure and static pressure. That can be related to velocity, right. So with the help of this simple device which is used for measuring the flow in a pipe, also in a river, for finding out the velocity of an aeroplane, of ship, etc. This is a device which is used for finding out the speed of aeroplane or speed of ship, because in case of the cars, bus, bike, we can find out the velocity with the help of some mechanical arrangement and we can convert into some digital signal, right. But in case of aeroplane we don't have any that kind of mechanical arrangement, right? So we have to have some kind of system, and this Pitot tube gives that system. So velocity difference can be evaluated with the help of this device, and velocity can be measured in ship and submarine and aeroplane with the help of this simple device. Thank you very much.